So I'm continuing with Joachim Domsta's paper, and I'm sorry for if I mispronounce the name. Hubble law obtainable for SRT model of the universe via the Doppler effect. Very short paper. Um, and in my last video, I got up to this rho value and alpha value. I calculated those confirmed. Uh, Oh, I did not confirm T over capital T, but I did confirm R over capital T. So I was just plugging those things into Mathematica without too much thought. And okay, yeah, T is defined. So what it gets for T over capital T is T over T plus TV. Huh, this is exactly the same value. No, it's not. This is TV over T plus TV. This is T over T plus TV. So there's a factor of V missing. So of course this can be simplified to be V over 1 plus V. And this can be simplified to be 1 over 1 plus V. And this turns out to be square root of 1 minus V over 1 plus V equals tau over T equals R over T equals T over T. Now he's got all of these in an expression involving alpha, and this one is R over T was 1/2 of 1 minus alpha squared, and T over T, which I have not quite confirmed yet, but he also has T over T is 1, oh, he has 1/2 of 1 plus alpha squared. So I'll just confirm that one real quick too. This would be 1/2 of 1 plus, and then we'll have 1 minus v over 1 plus v after the squaring. So, which is 1/2 of 1 plus v over 1 plus v plus 1 minus v, which is 1 plus 1 is 2, plus v minus v is 0 over 1 plus v times 1/2, so it's equal to 1 over 1 plus v. So confirmed, because 1/2 of 1 plus alpha squared, 1/2 of 1 plus alpha squared is equal to 1 over 1 plus v equals 1 over 1 plus v. Okay, I'd like to see if I can make this alpha term into a sort of trigonometric or hyperbolic trigonometry thing. And first of all, let's see what this rho is. Rho is r over t, which was this one. So let's call that rho. See if this comes out, because alpha is the square root of 1 minus hyperbolic tanh of the rapidity divided by 1 plus the hyperbolic tanh of the rapidity. And I'd like to see if alpha squared being, I don't know, it's cosh phi minus sinh phi divided by cosh phi plus sinh phi. It would be really neat if I could find a way to express this. What is cosh? Cosh is e to the phi plus e to the negative phi over 2 minus e to the phi minus e to the negative phi over 2 divided by e to the phi plus e to the negative phi over 2. All that stuff there. I could cancel out the 2's. This would be e to the phi minus e to the phi is 0. E to the negative phi minus negative e to the negative phi is 2 e to the negative phi divided by, and then this is the plus. This comes out to be 2 e to the phi. So yeah, e to the negative v over e to the phi would just be e to the negative 2 phi. E to the negative 2 phi. And that's equal to alpha squared. So yeah, alpha is just e to the negative phi. So I just asked Mathematica to confirm that, and it didn't want to. So I'll try plotting 1 minus tanh phi compared to e to the negative 2 phi graphs right next to each other. This looks kind of promising. Going from negative 1 to 1, we have it going from 0 to 6. Those look like very similar graphs. I'll have it go from negative 5 to 5, see what that comes out. Those look very similar. I think that this is a successful comparison. That 1 minus hyperbolic tangent of phi divided by 1 plus hyperbolic tangent phi does give us e to the negative 2 phi. We've seen it in graph, and we've seen it worked out in algebra, so it's pretty convincing. So we can also say that this is e to the negative phi right here. And rho is 1 minus e to the negative 2 phi divided by 2. And this thing t over capital T is 1 plus e to the negative 2 phi over 2. But we can do that more than that. E to the phi minus e to the negative phi over 2 e to the phi would be sinh phi over e to the phi. Odd. And this would be cosh phi over e to the phi. Not sure what relevance those things are going to have, but that might be a simplification you could use. Okay, the next thing in this description is z. Z is the redshift, and in terms of the wavelength, it's lambda emitted divided by lambda, can't even read that, it's too small. Okay, this has some strange highlighting, but here is the expression I'm familiar with. Actually, let me just go out to Wikipedia to find the expression that I am familiar with, which is this one right here. Motion completely in the radial or line of sight direction, 1 plus z. 1 plus z equals, and how did this relate to alpha? This says square root of 1 plus v over 1 minus v, because we are setting c equal to 1. Now his expression for alpha was tau over t, which was actually the reciprocal of this expression. So he has 1 plus z equals 1 over alpha, which would be e to the positive phi. So with all that in mind, let's look at this. Z equals, let me write that lambda e over lambda e minus lambda a over lambda e equals 1 minus alpha. That'd be alpha over alpha. No. That would be 1 over alpha minus alpha over alpha equals minus 1 plus 1 over alpha equals, this thing is 1 over alpha. So yeah, so z equals lambda e over lambda e is going to be 1 minus lambda alpha over lambda e, lambda absorbed divided by lambda emitted. So lambda absorbed is going to be like lambda emitted plus some delta lambda over lambda emitted, which in turn, so 1 minus 1 minus, so negative delta lambda over lambda emitted. I'm not sure where I'm going with this. I'm trying to get a reason for having a -1 here, and I'm not sure because that has a -1, that has a -1, and I'd like this to have some kind of -1 element to it. But since I am currently confused, I am going to check to see if this z matches what is on the Wikipedia page. He has z equals lambda observed. Yeah, he's got this reversed, I think. He needs the lambda emitted. Uh, yeah, lambda absorbed minus lambda emitted divided by lambda emitted. So that would probably fix it here. But I think that's the first typo I found. And it doesn't actually look like he uses that wavelength dependence later on. It's just going to be z plus 1. We'll have a z plus 1 equals 1 over alpha, basically. Z plus 1 is 1 over his alpha. And he can also say 1 over alpha is 1 minus 2 r over t, 1 minus 2r 1 minus 2r over t. Is that accurate? Let's see, I had calculated r over t to be sinh phi over e to the phi. So sinh phi over e to the t, e to the phi, I'm sorry, equals e to the phi. Is that accurate? Multiply both sides by e to the phi would give you e to the 2 phi over here equals e to the phi minus 2. Sinh phi is e to the phi minus e to the negative phi over 2. Those cancel. We have e to the 2 phi equals e to the phi minus e minus e to the phi minus, that would be plus e to the negative phi. Oh man, there's a square root there. Let me do this all over again. Okay, here are the identities that I'm going to use. Alpha, or tau, equals tau over t equals e to the negative phi. Little t over capital T is cosh phi over e to the phi. And r over t is rho, which is sinh phi over e to the phi. And we'll have to plug in z. Z is 1 over alpha minus 1, which would be e to the phi minus 1. So square root of 1 minus 2 r over t would be 2 sinh phi over e to the phi. And we want to compare that, or minus 1, we want to compare that to e to the phi minus 1. And we're wondering if it's true. That comes from there. Z is e to the phi minus 1. So sinh phi is e to the phi minus e to the negative phi over 2. So 2 over 2 cancels out. We're left with e to the over e to the phi. 1 minus that square root is going to be minus 1. It's going to be the square root of 1 minus e to the phi over e to the phi is 1. E to the negative phi over e to the negative phi is plus e to the negative 2 phi minus 1, which is square root of e to the negative 2 phi, or just simply, yes, e to the negative phi minus 1 equals e to the, whoa, did I get e to the negative phi? No, I got e to the phi minus 1 equals e to the negative phi minus 1. It looks backwards a little bit. Probably deserves to be rechecked, but that's what I got right now. So I'll erase that for now, but We've still got it recorded, so hopefully I can look at it later. Let's go ahead and look at the velocity equation. This has velocity equals 1 minus tanh squared. Wait, 1 minus, what am I saying? 1 minus, first of all, the velocity should just be hyperbolic tanh of phi. So if this comes out 1 minus e to the negative phi, no, yeah, 1 minus alpha squared divided by 1 plus, sorry, 2 phi, 1 plus e to the negative 2 phi would be equal to, if we just multiply that by e to the v over e to the negative v, that is e to the phi minus e to the negative phi over e to the phi plus e to the negative phi, which is equal to tanh phi. So yes, this part comes out right. Velocity is 1 minus alpha squared divided by 1 plus alpha squared is equal to hyperbolic tanh of phi. Now, is that equal to rho over 1 minus rho? Rho over 1 minus rho would be equal to e to the negative phi sinh phi divided by 1 minus e to the negative phi sinh phi. Now, sinh phi is e to the phi minus e to the negative phi over 2. So when we multiply that by e to the negative phi, we would get 1 minus e to the negative 2 phi over 2. So rho over 1 minus rho is equal to 1 minus e to the negative 2 phi divided by 1 minus e to the negative 2 phi over 2. Multiplying top and bottom by 2. Well, we're hoping to get hyperbolic tanh of phi out of this. So, but 2 minus 2e to the negative 2 phi divided by 2 minus 1, 2 minus 1 plus e to the negative 2 phi, which is going to be 1 minus e to the negative 2 phi divided by 1 plus e to the negative 2 phi. And if we multiply that by e to the phi over e to the phi, we'll get e to the phi minus e to the negative phi over e to the phi plus e to the negative 2 phi, which is hyperbolic tangent of phi. Okay, good. So yeah, that one was confirmed. This one, I did not quite get the same thing. I don't know whether that's my error or am I just, is that a negative 1/2? Yes, it is a negative 1/2. That changes quite a bit. Let's see what that changes. We would want to check whether e to the phi minus 1 is equal to 1 minus 2, 1 over, 1 over 1 minus 2 sinh phi over e to the phi square root minus 1. So I'll expand sinh phi into e to the phi minus e to the negative phi over 2. Take e to the phi over e to the phi, get 1. E to the negative phi over e to the phi minus gets e to the negative 2 phi, which comes out to be e to the positive phi minus 1, which is equal to e to the phi minus 1. So yes, that works. So I think in this paper, which is 1 page long, I found one possible typo and everything else is perfect. So the typo is right here and everything else looks like it came out just right. So thanks for watching.